And my clock is now saying 4:03, so I think now is a good time to get started. So hello, everyone. Welcome to the Virginia Clean Cities Technology Happy Hour. My name is Sarah Stalkup-Jones. I'm the Research and Heavy Duty Vehicle Program Manager and our Chief Equity Officer here at Virginia Clean Cities. And today we'll be hearing from Shankar Mukherjee with Virginia Transformer. So normally I would go around and have everyone introduce themselves, but since we actually have a decently sized crowd today, I think I would just request that if people are comfortable with it, to put your name, your organization, and where you might be joining us from in the chat. And please feel free to use the chat as a space to network and connect with each other. And I will go ahead and introduce our speaker now. So today we are joined by Shankar Mukherjee, and he is the Vice President of Market Development and Product Management at Virginia Transformer, the largest US-owned transformer manufacturer in North America. He is responsible for creating power solutions such as the E2V integrated power module that supports rapid deployment of electric vehicle infrastructure while addressing procurement and site installation issues. Prior to his role, Shankar has held many leadership roles in strategy and management, such as the Senior Director of Product Management at Stanley Black & Decker, Vice President of Global Marketing at Danaher, and Director of Marketing at Honeywell. With more than 20 years of experience in strategic marketing, global product management, business development, and engineering, Shankar has a track record of successfully leading teams in Fortune 50, 100, and S&P 500 companies. Shankar earned his BE in Mechanical Engineering from the Maulana Azad National Institute of Technology, his MBA at California State University, and his MS and PhD in Mechanical Engineering from Florida State University. So with that, I will go ahead and hand it over to Shankar. I know that you have a couple of other members on the VA Transformer team, so if you want to introduce them while I pull up the presentation,
Sure.
That would be a great way to start.
Well, thank you very much, Sarah, for having us on the call here today. So with me, we have Reena DeBerry, who leads marketing for the new markets, such as EV charging. We also have Kevin Lowry, who leads marketing communications. And then we probably have Avi Azulai, who's the EV charging market development manager for the West Coast. And then we have Mark Vecchiola, who's the EV charging manager for the East Coast. So great. Hey, thank you so much for coming and listening to us. Really, it's a pretty exciting topic. We want to kind of discuss some pretty interesting things with you, primarily how to implement EV charging infrastructure. So Sarah, next slide, please. So McKinsey and Company, did a study last year where they looked at the ZEV car park growth to 2030, factoring factors like the NEVI program, and also I'm sure you guys all know the U.S. federal government has a target to get to 50% of all car sales in the U.S. to be ZEV. So then they broke that number down to what would be the impact in terms of numbers for battery electric vehicle, and came to a staggering number of like 48 million. And then they broke it down to the number of charge points needed to be able to serve these markets. So that came out to be like 1.2 million, public and fleet chargers. So if you think about where we are today, end of 2022, all the data we have points to we have maybe about like 164,000. So the growth delta from like where we are now to where we need to get to is pretty daunting. So as it pertains to the EV infrastructure, we're going to focus on like three key areas today. So number one, expected and unexpected pain points for building EV stations. Number two, is there really a need for standalone transformers, rectifiers, and switchgear? And number three, will long lead times for transformers and switchgear force the industry to go a different route? Like, for example, we are hearing from our customers that they're seeing market lead times of transformers about 50 to 60 weeks. And for switchgear, they're seeing about 80 plus weeks. So that is, well into a year and a half or more for deployment. Next slide, please, Sarah. So you guys will think, okay, why is a transformer manufacturer be so interested in EV infrastructure? Like isn't like the transformer supplied with utility? Is it really something that I need to worry about? So the answer is, with the ever evolving and rapidly changing landscape of EV infrastructure buildouts, you really need to look at each aspect of the value chain and review it really closely. So again, why a transformer company? Well, we have expertise in moving energy, and we've been doing it for 50 years. We serve a number of varied markets. We do utilities. Most of our transformers are certified certified by the utilities. We do renewables. We do a vast section of commercial and industrial markets. We do data centers. We also do EV charging. So we go across a wide variety of markets, and we make products ranging from 500 kVA all the way up to 400 MVA. So, and we do it across 6 production facilities. So that's sort of with all the deployments and in different markets. So we started having a better perspective of how do we help this particular industry and where the pain points are going to be. Next slide, please. So looking at, okay, how does energy or power get from utility to the electric vehicle? Again, this may be 101 for many of you, but I just thought we'd kind of go over it a little bit so we are grounded we are on the same page here. So even beyond the left of this particular slide, you have a transformer which takes transmission voltage and drops it down to distribution voltage at a substation. And then if you're looking at charging station side, basically the process starts by connecting the utility distribution network or electric lines to a transformer. So we can take that power and then and drop it down to 480 volts, which is typically what you would need for most fast charging. Or in some instances, we go one more step. You have to drop the power down to like 208, 240 if you are doing a level 2 equipment. So then you have to install all the different other things like primary or secondary metering as required by the customer on the site. You have a main breaker, you have distribution switchgear to distribute the power from 480 volts down to each of the individual rectifiers connected to each charge point, or to in the situation where you have integrated rectifiers to the charge points themselves or to level 2 chargers. So if you look at all these different steps, I'm counting at least 6, and there could be much more. So next slide, please, sir. So each of these steps has their own pain points. And we kind of list. If we go through a list, I'm going to talk about things like, okay, you got to procure each individual components, and each of the individual components has their own separate lead time. So you're always chasing your tail in terms of figuring out where the lead times are going to be at any given point in time. And then you have the logistics of procuring each individual item. So you have to procure transformers, you're procuring switchgear, you're procuring conduit, you're procuring cables, wiring. Somebody has to do all the program management. And then you have all the installation issues, such as finding qualified trained labor that will support reimbursement if you're grant funding. Installation of different vendor components. A lot of times, components come into the site and they don't fit. And then you got to do all the digging and trenching. And then the other thing would be, for example, the fourth one would be, finding, funding either through capital raising or grants at both the federal, state, or other sources like the utilities. Also you got to make sure because you stay on target, because that's some of the requirements of the funding. And again, these are some of the most obvious pain points, but there's also unexpected pain points. Like for example, start with installation and you find out you need special adapters, or you got like bad weather and it sets you back. So even within the existing system, all of these pain points can be overcome with lots and lots of time. But when I was talking about the numbers a few slides ago, how do you get from 164,000 stations now to like 1.2 million plus? And in addressing the pain points in such a manner that you can actually meet the timing that's required for the 2030 federal targets. So next slide. So you got to think differently. So within the EV infrastructure community that we've seen, there are multiple companies that are thinking differently to come up with solutions, which are, for example, Navy ready, and it also eliminates steps and coordination. Also can be quickly deployed. So we're showing a few examples here. So, for example, DC Americas, they're building charging platforms, integrating the chargers and rectifiers on a single skid or a platform, as they call it, which is pretty ready to be installed on site. Technically, you can lift up the whole platform and move somewhere else if you really need to. Plus, the footprint is pretty compact. Then you have other companies like, for example, Franklin Electric, which is solving a smaller part of the problem. They're integrating low voltage switchgear with monitoring. So in the chain that I showed you a few slides ago of the different components of the station, so they are maybe solving a couple of the steps, and then at Virginia we have combined at least 4 of the steps. So we are leveraging our expertise in moving energy by combining medium voltage breakers, switchgear, transformers, a main breaker panel, and also low voltage distribution, all into one single unit, which is assembled in the factory and shipped completely assembled. So complete plug and play. You connect primary and you connect the low voltage side, and you're ready to go at a fraction of the station's footprint of the individual components. So you're saving a lot of real estate, and you're also saving a lot of time and pain because everything is integrated. So each of us, like for example, DC Americas, Franklin Electric, and Virginia, we're trying to leverage our expertise to find a unique solution to help solve and build out requirements by looking at the problem a little bit differently. Next slide. So there's multiple ways of so you have to hit those arrows. I think when I can you hit the arrow a couple of times? Yeah, one more. Yeah, awesome. So there's multiple ways of even utilities are getting in the business of thinking differently. So like for example, in a traditional build out, the utility companies would support a site through the meter, but also because of the funding and rapid deployment of EV infrastructure build outs, the utility companies have also come out with different ways. For example, there's what they call the make ready concept, which is essentially pre-wiring all the electrical infrastructure at a site by the utility company to enable it to accommodate a charger to easily and also efficiently. So that includes all your service panels, junction boxes, transformers, meters, things, conduits, and wiring, etc. So they're also trying to think differently. Also, due to capital investment and lead times, owner operators also thinking differently by taking more ownership of the whole process from the transformer on, using what they call essentially a reverse of the make ready concept. So each of these methods has their own pros and cons. For example, all the different pain points that I talked about. So what would be the final what would drive the final decision is really the completion deadlines, right? So and also your budgets and your availability of materials. Next slide, please. So at Virginia, our goal was always to think about looking at solutions that could be installed in a day, also with as much little labor as possible, and a much smaller footprint. So that integrated module, we came up with the concept called E2V, integrated power module, which essentially consists of medium voltage breakers, a dry transformer, a main breaker panel, and also low voltage distribution, all into one single unit. So that if you look at the traditional site, we are removing the transformer, the voltage breaker, the metering, and also the boring and trenching and everything else which goes along with it. So essentially, you end up with a solution which is pretty much plug and play, and you're also condensing that total infrastructure into a much condensed footprint. Next slide, please. So this gives you a little bit of a better feel of what the technology is. Essentially, you can see the medium voltage breaker on the left, the transformers inside. You also see the main breaker panel, and then in this particular instance, we configured it for about six chargers. So these type of solutions can can support both your fast charging as well as level 2, and then it can be configured to each individual site needs. So whether you have 8 chargers or 9 chargers or 4 chargers, these type of solutions can be configured to make your life simple. Next slide, please. So I talked about one of the driving factors for us to think differently is really the implications of the federal government requirement where 50% of the vehicles to be ZEV. I talked about in the beginning some data from McKinsey. This is another set of data from PricewaterhouseCoopers, where you're looking at the build from where we were in 2020 all the way up to 2040. So if you look at it, instead of 48 million, they're projecting about 35 million by 2030. They're also projecting about 8 million charge points compared to 1 million for commercial public charge points and fleets. So whether it's 1 million or 8 million, it's still pretty big. So I'm also including all the government needs. You've got government people, government entities, you've got school buses, and then you have the fleets. So if you look at the curve, it looks pretty gentle. And then if you were on pace, then we would be able to certainly meet those deadlines. But if you think about the pace now, what we are forecasting is that you'll see a big hockey stick somewhere about like 2025 to 2029, 2027, because right now we are on a much shallower slope than what is being shown on the graphs. So to be able to meet the deadlines, people will have to really deploy much faster than what is needed, and that's what's going to contribute to the hockey stick. So to be able to, even if you are on a good track, to be able to meet these deadlines, there has to be a balance, between manufacturing, procurement, and also installation of components. If any one single piece of this is off, that's pretty much is going to throw off the timeline. And then you factor in the hockey stick. So it is going to be a pretty aggressive and fast build. Next slide. So as I mentioned, a key component of the grid to power the grid are transformers, whether standalone or part of an integrated power module. So you can see some of the articles in the news here, and we are showing a sample. People talking about the transformer crisis. As you know, the average age of the transformer of the grid was 60 years, and on top of that, transformer capacity is limited in the industry. So you can see a lot of the articles show up now. So this is an article from in February where they're talking about now, because of the charging infrastructure deployment issues, they're actually talking about whether does it even make sense for us to go fast on EV truck production and deployment. So there's a lot of activity and a lot of angst in the industry about how do we actually solve some of these problems. So all of this, all these concerns that I talked about, they're all valid concerns. But for us, at least on the transformer side, we're not really worried about the shortage. Next slide, please. So we are committing to having the shortest lead times in the industry. As a matter of fact, we just opened up, just to be able to meet the industry deadlines and requirements. We opened up a brand new plant in Mexico last week. So that plant is already full. So really, we are trying our best to make sure that we can support the industry. So for example, the IPM, or the integrated power module I talked about, is about 28 to 32 weeks, and compared to that to industry lead times of 50 to 60 plus weeks. We, as I mentioned on one of the slides, the substations. So we also do substation transformers, and those are also at 55 to 60 weeks, which is also the fastest in the industry. Next slide. So really, what I want to leave you is with a thought of how do we think differently? So we need to think differently about procurement. We need to think differently about installation. And we also need to think differently about how to build out these charging stations. So I think that's I think pretty much what we wanted to cover today. I will probably open up the floor now for questions, Sarah.
Thank you for that awesome presentation. Like Shankar said, now we are going to take some questions. So first, I'll take one that we got in the chat. But then as we go, you guys can feel free to just unmute and ask or raise your hand or put them in the chat and I will read them out. We are recording this session, so it'll be going up on YouTube sometime probably next week if you missed the first half of the session or want to reference it back. But I just thought I would let everyone know that as well. So the first question that we got was from Andy Alden, and this is referring to the rectifiers. Are those only referenced WRT DC chargers, or are they also relevant to EVSE installations?
Yeah, so EV, so any station which has fast chargers, 180 kilowatt and below fast chargers usually have this rectifier built into the charger. And then anything in the range of 180 and above, or actually above 180, you have a separate box, which is the rectifier, and then you have a charge point. Is that the question? And is that answer your question?
Yes, thanks.
Awesome. Thank you for that question, Andy. The next one that I am seeing in the chat is from Ben Kessler. What type of cost savings could one expect going with this type of transformer? They assume that the utility infrastructure, not including the transformer, costs are lower, but what about the transformer equipment itself? Yeah,
so you have to think about a problem holistically. So in a site build, you have the transformer cost, you have the switchgear cost, you have the main breaker cost, you also have the rectifier, and then the charge point cost. But for this question, we're talking about procuring medium voltage switchgear, procuring transformers, procuring main breaker, procuring low voltage distribution, and then doing the digging and for each of these to lay the conduit and then connecting all the wiring. So if you look at the total overall cost, and it'll vary from site to site because of the site configuration, and depending on how many, what size site, what size unit. But and again, so I cannot give you one standard answer, but it is going to be a significant. It'll be a fraction of the overall cost that you would have if you had to do it separately, including the cost of the product and the hardware. If you compare the total versus just with the IPM.
Appreciate it.
Thank you for that. And then we have another question in the chat, which is if you could give an estimate for the budget for a unit to handle like 8 chargers. Is that something you're able to do?
Well, it depends. Again, it depends. Like, for example, you could have 8, 180 chargers, 180 kVA kilowatt chargers, or you could have 8 350 kilowatt chargers. So you're going from somewhere about, let's say, a 1000 kVA unit to a 3750 kVA unit. So it depends on the requirements. And then there's also site requirements. For example, whether you need to put in an additional power transformer inside the unit to drop from 480 to 208 for level 2, or even for powering your the displays on the chargers. So it is, if there's any specific configuration or sites that you want to look at, we can easily cost it out for you guys. Again,
Excellent.
Not trying to be vague, but it varies from configuration to configuration of the site.
I feel like it depends is a big thing with EVSE installation.
Right.
So definitely. And next, I see that Andy, that you have your hand raised. If you want to go ahead and ask your question.
Sure. With the recent attack on utility substations, there was a discussion about how a lot of the larger transformers are actually custom built, built to order. And I'm wondering, is that same thing true of a lot of charging installations, or are these fairly standard transformers that it's something that you would keep on the shelf and ready to ship? And I guess also, as maybe a second part of that question, is why is there a shortage of transformers? What are the challenges that are creating a shortage of transformers?
Yeah, so let's take the first part of your question, which is for EV stations, the problem is not the security, but you have, many EV stations are usually down because somebody runs over the cable with the car, and then the station is down, or maybe the display goes off. The transformer typically doesn't go down, but there is a nuance. If you are looking at DC fast charging stations, which have rectifiers involved in them, because of the power electronics in the rectifiers, they give off a phenomenon called harmonics, where now, again, I don't want to get too technical, but AC current is sinusoidal. So you have, most transformers and switchgear like the sinusoidal currents, but because you have these harmonics flowing backwards into the transformer from the rectifiers, the AC current is not so sinusoidal; it's more spiky. And these kind of spiky currents produce heating effects in transformers which are not built for harmonics. So a lot of times we tell our customers, if you are getting a plain Jane transformer from the utility and you have fast charging station, you need to think about whether that you need to go make sure you measure harmonics coming off the rectifier to make sure that transformer can handle it. But when we design these IPMs for particular applications, we take into account phenomena like harmonics. So to make sure these products can last a long time and not collapse because of heating effects after a few years, because we forgot to design it for harmonics like a standard product that you might get from a utility.
Okay.
Does that answer your question, Andy?
Well, I guess I was getting at too. Are transformers at the size we're talking about for, say, DC fast chargers? Are those a fairly standard item, or is each one of them custom built? Is that something like people would have in stock, like a supplier like yourself, or is that something that once it's damaged, it has to be built as a custom order, and then you maybe talk about some delay?
So we have a 24 to 28 week lead time, but people would not keep these transformers in stock most of the time. So, but what we have done is with this product that I showed, we have tried to standardize it as much as possible. Given the fact that some amount of non-standardization will occur because of the EV charging station layout, whether it's like 6 chargers or 8 chargers or 10 chargers, but the rest of it is probably as standardized as we could get. And so what we're doing to be able to meet those lead times, we stock a lot of these breakers. We also stock a lot of transformer components, so we can be ready to go build when the customer needs it. But the most times what you'll find, Andy, is the transformer is not the long pole in the tent. It's really the switchgear, right? So we have taken some of the P and out by combining many of those into one single unit. Okay.
And you saw one of your slides, so it's something about a transformer shortage. What is the nature of that? Why is there a shortage? Or is it come down to materials or manufacturing, or what is it? Why is that happening?
So now you have a confluence of several different factors. You have supply chain issues, which started during COVID, and then you have till last year you had Bitcoin, which was cropping up everywhere. You have data centers, massive amount of data center construction. And then also from last year, with the flow of NEVI funding, you have a lot of stations coming up now. So the demand for transformers has probably, quadrupled or even gone 5 or 6 fold. So the industry capacity is not there to be able to suddenly take that kind of a supply chain shock. So that's why you see all the lead times. So we have tried to mitigate it with making sure that we standardize some of these product offerings, and also we stock a lot of different components. Plus, we can shift around production between different plants as and when the demand flows. But not many of the other companies are able to do that. So I think that is contributing to the crisis. The other thing is, you have to remember is, and I said in the beginning, this is not going to go away in anytime soon, because the average age of the transformer in the grid is 60 years. So many of those transformers are also reaching end of life. So when we see those transformers going, reaching end of life, then you'll see the demand even spike up. So, but we are trying our best to make sure we have at least lead times which enable it to be up and running in 28 weeks, which is like what, 5.5 months, 6 months.
Great. That's really interesting. Thank you.
Yeah.
Awesome. Thank you for that question, Andy. And next, Dave Gilman, I see your hand is raised.
Yep. Thanks, Sarah. Shankar, I thank you very much for addressing us all today. We're really glad you're here. I'm looking at it going, okay, everybody's talking about what's happening, thanks to NEVI. Okay, those stations are for 150 kilowatt charging units.
Mhm.
Can you talk a little bit about how you approach it differently, or what you're looking at when you're starting to also look at fleet applications, particularly medium and heavy duty fleet applications, where the sizes may absolutely swamp that,
Yeah.
not necessarily in numbers, but in size? And
Yeah.
also, is it bigger transformers? Is it more transformers? Is it some of both?
Yeah. So with the IPM, as you correctly mentioned, we have configurations for NEVI, which are like 150 which can do 100. So mandate is 150 kilowatt. Let's say you want to have at least six, just to have at least a decent station size. So you're probably going to build like 6 of those 150. So you're really talking about a 900 or a 1000 kVA transformer. Now, when you look at fleets, you might have 8 350 kilowatt chargers. So that would be like a truck station. So now you're looking at a 3750 kilowatt charger. So we have IPMs ranging in size from the NEVI ones, or even smaller, to all the way up to these fleet applications where we have like much bigger transformers in the IPM.
Okay.
Does that answer your question, David?
Yeah,
Yeah.
pretty much. I mean, it's kind of a completely different approach that you have to take for a fleet application, and
Right.
yet some of the numbers may grow pretty fast. If you got 50 or 100 medium duty delivery trucks in one spot,
Yeah.
you're talking about way over, multi-megawatt charging levels
Yeah.
in one spot. We already know the utility industry has their issues with that, but I was wondering, as the guy in the middle, how you all address that.
Yeah. So let's say you have a 20 station, you would not be able to do it with single one. So we would probably give you we will provide the customer at least 3 of these. So we would look at their single line diagram and figure out what power they would need and how many IPMs they would need. But the other thing which is also coming up is the battery capacity, or the ratings of batteries for trucks are going up. So they're talking about already at 800 or 900 volt, even 1000 volt battery in some of these trucks. So the next phenomenon which is going to come in the next, we have already seen demo units, but for example, companies like ABB have come up with what they call a megawatt charger. So that charger is, some of the charger we have seen is about 3.75 megawatt. So each charger can, they're designing this, particularly it started with Europe, where there is a requirement that when the drivers stop, they have to, they stop there for at least 15 minutes at a certain period of time. So we have to be able to, charge up a truck within those 15 minutes. So hence the current rating and the power of the chargers are going up. That has been shown in the US, but it hasn't caught on yet, but I'm sure that it's coming. But you talked about 350 kilowatt. Right now, we are starting to see, we will see pretty soon ratings in the 600 to 400 to 600 kilowatts pretty soon. So obviously, you will not be able to handle the station size of 20 units with 600 kilowatts chargers all with one IPM. So you will have to have multiple IPMs, possibly daisy chained.
Okay,
Long
thanks.
answer to your
Appreciate it.
question.
Awesome. Thanks for your question, David. And now we have a question from another David on the call. David Howell asked, having driven from Virginia to Florida and Canada in the past 2 months with their Lightning, there have been noticeably more and more broken chargers. Last year, they experienced relatively smooth sailing. Can you speak to the plan for getting technicians to repair these units as more and more transformers come online?
Yeah, so I mean, we really don't see a lot of issues with transformers. So those things are pretty robust. Where we see issues are if transformers are not configured. So I talked about the harmonics, but that doesn't show up immediately. That'll show up in a few years. But most of the charging station woes that we see are, people driving over cables and the charging cable, or they leave it on the ground and it's all over the place. As a common root cause, I'm sure there's other things as well. But when we have a transformer down, we build in charging stations, service programs. So depending on the customer, if they want to get a service immediately, we will have a servicing plan where we will get either our people or our partners to come and repair the transformer within a short amount of time as specified by the customer. So in general, not just EV. But so we can handle the transformer part of it, but most of the issues that we see right now are really the issues we have on the charge point side.
Excellent. Thank you for that. And now, this isn't necessarily a fully fledged question per se, but when we had people register, we had quite a few people note that they would be interested in learning about anything related to workforce development or expanding the workforce around EVSE and transformers in general.
So we are starting up a line in Virginia for these particular EV products as well. So I think that would be also, it would satisfy the it would be product made in the U.S. So that I think is going to serve employment or provide employment to a number of so we will probably have like at least 60 to 100 people in the plant. So that's the plan to as social citizens to be able to increase employment in the Roanoke area. I'm not sure that answers the question fully, Sarah, but I tried as best as I could.
Yeah, if anyone here is on the call and has like further in-depth questions, I would invite you guys to ask them now. But considering I was just given workforce development as a general interest, I think that's a great answer. Right. And does anyone else have any questions? Bruce, I saw that you came on camera.
Shankar, thanks for giving this talk. This has been great. We have some of our utility partners on the call, and we're so thankful they're here to hear your presentation. You're already doing a lot of innovative work, innovative products. This is just kind of a big picture question, and please only share as much as you're willing to, proprietary information. But where do you see, the grid going in future years with more and more electrification? Not only vehicles, but more complete electrification in homes and so forth.
Yeah.
How are you all preparing for that as a company?
Let me start with the external environment, which is really what's happening outside. And you can see there's studies already available from National Grid in particular, where they did a study on looking at mass and New York State, and looking at the current EV charging stations and what would be required to be able to hit the federal mandates as well as the New York State mandates. And what they're saying is now is if you're thinking about some of these numbers that I was just tossing out, a 5 megawatt install is very close to what you would need in a factory. So and then you talk about increasing the number of stations. Now you're talking about 40, 50 megawatts. They have to do things differently. They're talking things about, okay, can we move instead of having distribution? Can we find a way of dropping from transmission to the charging station as examples? The other phenomenon you will see which is also coming up, is smart grid in general, where you have transformers. In the future, transformers can regulate power depending on the demand by themselves, based on how you program it in there. In the short term, you have this phenomenon called vehicle to grid. So you will have to have transformers built for that. So we are looking at technologies of even innovating that we would look at what we did with the IPM, but go one step beyond and looking at how do we address smart grid or even vehicle to grid solutions with products which are more amenable to that. Let me just leave it at that.
Thank you.
Excellent. Thank you for that question, Bruce.
Sure.
Right, and I will leave it open for a second. Does anyone else have any more questions? Also, you can feel free to put them in the chat if you do, and I'll read them out. We'll give people a second. All right, I don't see anyone with a hand raised or unmuted, and the chat seems to be a little bit quiet. So I think that this will be a great time to end. Like I said, I will be sending out a copy of this recording. It will go up on our YouTube channel, but you guys will be getting that sometime next week. It'll go to the email address that you registered for the session with. But if you guys have any questions after the fact, definitely feel free to reach out to Shankar and the VA Transformer team, or you can reach out to us at Virginia Clean Cities and we can connect you over there as well. But I wanted to thank everyone for coming. I also wanted to let people know that this is a monthly event. So if people are interested, I would like to encourage you to join us next month, focused on renewable propane with Blossman gas. So the registration link for that is in the chat. But again, thank you, Shankar, and thank you to the whole Virginia Transformer team. We really appreciate it. And I hope that everyone has a great rest of their day.